Hi, welcome to the periodic table on background. We take for granted this amazing chart, the periodic table. You're going to find out that there are layers upon layers upon layers of information that are all hidden in it, and you're going to learn to extract that information. So, such a neat thing, such a useful tool. Where does it come from? Well, as you know, by 1808, Dalton had proposed his atomic theory, and it was widely and well accepted by chemists. So, by 1860, a lot of chemists were working with this idea, but the thing that still wasn't nailed down was a standardized way to measure atomic masses. So people used whatever mass they measured. There were no standards. It was kind of a mess. In 1860, an international meeting of chemists established standards for atomic masses and how to measure them. That was fantastic, but there were still a whole bunch of elements and still no good or organized way to present information about them. Enter Dmitri Mendeleev. He was a Russian chemist and a professor at the University of Petersburg. He's the one who developed what is the ancestor of our modern periodic table. He did this in the process of writing a chemistry textbook. He was teaching a class and he couldn't find a textbook that he felt was appropriate, so he wrote his own, The Principles of Chemistry, first published in 1869. Now, you wouldn't necessarily recognize Mendeleev's periodic table. For one thing, it only contains 60 elements. That's compared to the 118 we know today. For another thing, those elements were arranged mostly by their masses. His rows and columns were also reversed, so what we look at as a vertical or downward order on his table was horizontal. Just a couple big differences. Now, as for Mendeleev's arrangement of the elements by mass, in 1869, there was no knowledge of subatomic particles. So the idea of atomic number was just the order that the elements appeared in on the periodic table. Mendeleev's work wasn't the first arrangement of the known elements, and it wasn't the only arrangement of the elements. What made it really groundbreaking was there were a few places where Mendeleev reversed elements, put them out of order of mass, in order to have them better arranged based on properties. And more importantly, he left spaces. He predicted, quite boldly, that there would be elements discovered that would fit into those spaces, based on their mass and their characteristics. Pretty cool stuff. Now, enter Henry Moseley, a British physicist. Moseley began to do some work with the periodic table and used X-ray spectroscopy, that's bouncing X-rays off samples of various elements, to determine that there was actually a physical and a mathematical basis for atomic number. Though this occurred in 1913, a big year for chemistry and physics, there was still no knowledge of the proton itself. All Moseley was able to show was that there was a ratio relationship between what we would later come to know as nuclear charge, or number of protons. Based on Moseley's work, a few elements were rearranged into an order that we would later know was the number of protons. Periodic. So, let's define that. Periodic is something that happens on some regular interval. Any event or pattern that occurs and reoccurs at some regular interval is called periodic. So, your schedule of classes throughout the day is periodic. The seasons are periodic. The hands on a clock are periodic. Though Mendeleev had originally stated a principle of chemical periodicity, saying that the properties of elements were a periodic function of their masses, it was Moseley's work that refined that into what we now know as the periodic law. This states that the physical and chemical properties of elements are periodic functions of their atomic numbers. And of course, we as modern people know that atomic number is just equal to number of protons. Okay, so on to the table itself. You've learned by now that there are 5 broad groups of elements on the periodic table. The metals, which is everything here. It's a pretty big group. The non-metals, a much, much smaller group, but pretty important to life as we know it. The metalloids, which are these oddball elements that run along this jig-jog, zigzag line between the metals and nonmetals and have some characteristics of each. The noble gases, this group right here. And of course, the ones that you don't know much about yet, but you will learn, the lanthanide and actinide series. That's these guys down here at the bottom. Of these, the 2 groups that were completely unknown in Mendeleev's time are the noble gases and the lanthanide and actinides. So we'll talk a little bit about those. The noble gases were added to the periodic table after the 1894 discovery of argon by Strutt and Ramsay. Helium was already known to exist, and the 2 behaved so much alike, being unreactive and all, being gases at room temperature, it was proposed that they be put into their own group. Krypton and xenon were discovered and added to the group in 1898, and radon was discovered in 1904. So we had one more column. The lanthanide series, atomic numbers 58, or depending on who you talk to, 57, through 71, and the actinide series, atomic numbers 89 or 90, depending on your source, through 103, are very heavy elements. These are some of the big guys. They're typically shown underneath the rest of the periodic table, merely as a space saver. The lanthanides are also known as the rare earth elements, and the actinides are all radioactive. That's about all you need to know about them to start off with. Okay, that's your background on the periodic table. You will have a 5-question recall quiz online when you walk in tomorrow. Have a good night.